Hello everyone, I hope you all are good and you all are practicing questions. With this one, we are going to start with a series of gravitation questions taken from the book S.B.T. So let us start with the first one. So what is given in here? I mean, there are 2 point masses, m and this m, and they are held at rest at a large distance from each other. So this is small m, this is capital M, and initially their separation is almost equal to infinite. Okay? When released, I mean, this mass is held here, this mass is held here, and now they are allowed to be or allowed to exist in a natural way. In that case, what will happen? I mean, they will start feeling gravitational pull of each other, right? So gravitational pull of this mass upon this one will let it go in this direction, and similarly this will start moving in this direction, because gravitational force is attractive force, right? This is attractive field. So under the effect of gravitational field, these two masses will start approaching each other. So that approach will start. अब देखो हमसे पूछा क्या जा रहा है. First of all, we have to calculate relative acceleration when separation between them becomes x. So let us first work on this first one. So what is happening? Initially, these two masses were at infinite separation. Okay? So initially this is this. Now at certain time, what is given? This between these two masses, separation is x. And here we have to talk about what will be the relative acceleration. Done it? So let's say this is particle 1 and let's say this is particle 2. Let us now define the direction. Let's say this direction is the positive x-axis direction and this direction is taken as negative x-axis direction. Okay? Now let us talk about force acting on first because of 2. So that will be equal to gmm by x ka square at separation x, right? And force acting on 1 because of 2 will be in which direction? It will be in this direction. So this force is in I cap direction. So what will be acceleration of first particle? That will be this force divided by the mass of the particle, that is this. So this is equal to gm by x square in the I cap direction. Now let us talk about force acting on 2 because of 1. So force acting on 1 because of 2 is related with force acting on 2 because of 1 in this way, right? So by Newton's third law, it will be equal and opposite. So it is like this. अब देखो F21 magnitude wise it will be same. Done hai? And its direction is going to be in which direction? Minus I cap. You can see here, second mass will get attracted towards the first one. So upon this, force acting is in this sense. Okay. So this is this. Now what will be the acceleration of second particle? That is going to be force acting upon it divided by mass of it. So its mass is this. So it will be this thing. Now, acceleration you are going to get at gm by x square minus I cap. Now, we have to calculate relative acceleration. Let us talk about it. So, let's calculate acceleration of 1 with respect to 2. So, acceleration of 1 with respect to 2 आप कैसे निकालोगे? You will be doing a1 minus a2. So, let us do that. a1 is how much? That is your gm by x square I cap minus gm by this is small m by x square in minus I cap direction. So overall ये minus minus plus हो जाएगा and you will be getting g by x square m plus m in I cap direction. ठीक है? So this is the relative acceleration of 1 with respect to 2. Relative acceleration of 2 with respect to 1 अगर आप निकालते हो, magnitude you will be getting the same, only direction will get reversed. ठीक है? So what is going to be our answer for relative acceleration? gm plus m by x square. This is going to be the magnitude. Now in the second portion, what we are asked, integrate the expression that we are getting in first one in order to calculate relative velocity of two masses when their separation is x. So basically we have to integrate this a. अब देखो इसका integration हम करके कैसे ला सकते हैं? So acceleration को velocity के term में we can write it like this. But here as a function of x we have to calculate velocity. So a को आप x के term में भी लिखने की कोशिश करो. You can write it like this. Divide it with dx, multiply with dx. like this. So dx by dt will become v and this will become v dv by dx. So acceleration is also written in this way. और ये काफी इंपॉर्टेंट है, बहुत सारे क्वेश्चन में आपने इनकाउंटर किया होगा. Either acceleration you write like this or you write like this depending on whatever is the situation. ठीक है. सो हियर वी नीड टू गो विद दिस वन. अब आप ध्यान से यहाँ पे देखना कि आई मीन ग्रेजुअली व्हाट इज हैपनिंग, ग्रेजुअली दे आर कमिंग क्लोजर. So x is decreasing, right? And when they are coming closer, their attractive force is increasing, meaning their velocity is increasing, right? So velocity is increasing. And when you write acceleration here, I mean acceleration has to be what? It has to be positive, right? So v into क्या लिखोगे आप? V into dv by dx. And dv here is positive, right? dx is inherently negative because x is decreasing with the time. And in order to make this acceleration positive, you need to give here negative sign. So यहाँ पे मैं लिखूंगी minus v dv by dx. And this I will write as gm plus m by x square. अब आप प्रॉपरली इसको इंटीग्रेट करो. सो v dv आप एक साथ ले लो and then this constant term you take it out of the integration sign and then put your negative sign and then you are left with what? 1 by x square dx. Now let us put the limit. Initially these masses are at infinite separation and at that point at infinite separation their velocity is 0. And at separation x, let us say velocity is v. So this will become v square by 2 and this will become minus g m plus m, ठीक है, divided by how much? This will become minus 1 by x and limit will change from infinity to x. So this will become how much? This will become minus 1 by x. So minus minus it will get plus. So v square is equal to 2g m plus m divided by how much? X. So basically v square is this much. What will be the velocity here? So velocity will be root under 2g m plus m by how much? X. So this is going to be your answer. Now let us talk about the third portion. Write the velocity of center of mass of the system when separation between them is x. So we are asked velocity of center of mass. We can clearly say it will be 0. Why? Because we are talking about system. Velocity of center of mass of the system. Or system क्या है? System is this and this. Initially they were at infinite separation. So when they were at infinite separation, they were at rest, right? So their momentum was 0. At separation x, they are having velocities, but I mean they gained velocity because of what? Because of internal force acting. Because gravitational force acting on a small m because of this capital M, that is acting on first particle because of 2. Because of this force, first particle is moving and second particle is moving because first particle is applying force on the second particle. So basically whatever force is causing their motion is internal to the system, is the internal force, is the force operating between these two masses which together is forming the system. And you know that when force acting is not external, when this is 0, internal force cannot change the momentum of system. So initial momentum was 0, final momentum has to be 0. So final momentum you will be writing as mvcm, right? So vcm is what? It is going to be 0. So finally अगर velocity का relation भी पूछता है ना, you can talk like this. अगर suppose कर लो इसी question में हमसे पूछा होता कि दोनों masses की velocity क्या होगी. So you will do one thing. Initially they are at what separation? They are at infinite separation. Their kinetic energy is 0 and their potential energy is also 0. क्योंकि potential energy आप कैसे लिखोगे? Minus g m by r. Why minus always? Because field is attractive, as I said. Attractive field है, potential energy negative लोगे. Initially r is infinity, so this is 0. Both are 0, right? At separation x, let's say this has a velocity of v1 and this has a velocity of v2. So they will have energy. Initial energy is 0. Final energy also has to be 0 because finally, I mean their motion is happening under conservative field, right? And in conservative field, energy, mechanical energy remains conserved. Initially it was 0. Finally it has to be 0. So final energy half mv1 ka square plus half mv2 ka square. This is kinetic energy plus potential energy, that is minus gmm by x, it has to be 0. And second equation you can write from conservation of momentum, mv1 has to be equal to mv2. You can solve these two equations in order to get their v1 v2 separately. So you could have done a lot in this question. I hope it is clear conceptually and mathematically both. But if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself and keep on solving more number of questions. Bye bye.